Yeah, well, hello everybody. Thanks for coming to my talk and not attending the maybe more interesting hyper talks at the other venue. I really appreciate that. And my name is Jennifer Schneidereit. I was expecting that in Germany people would be able to pronounce it, but okay. And I'm one of the co-creators of Tengami. And Tengami is a game that takes place inside a realistically folding 3D pop-up book, as you might have guessed from the title. And in the process of making Tengami, we developed our own game engine, plus an advanced set of tools that allowed us to build a digital pop-up world. And in this talk, I want to share with you our approach in making our own game engine, plus some of the thought processes and reasons behind it, as well as giving you a live demonstration of the tools that we created. So I want to kick off with doing a proper introduction of myself. I was born and raised in Germany, and after graduating with a degree in computer science, I joined a developer in Japan called Acquire. And I worked with them as a programmer on 2 titles, Shinobi do Homura and Where's the Samurai, which are basically ninja and samurai action-adventure games. And after about 4 years in Japan, I decided that it's time to seek some new opportunities. And I joined Rare in the UK to work on one of the launch titles for Microsoft's Kinect called Kinect Sports. And it was while working on Kinect Sports that I met Phil in Rio. And at the end of 2010, we decided to leave mainstream development behind to seek creative fulfillment and start our own tiny independent studio that we called Nyamyam. And I think in total, I've been making professionally games for 10 years, for 5 years in in mainstream development as a programmer and a game designer, and 5 years independently. Tengami is the first game that we released at Nyamyam, and also so far our only one. It took us 3.5 years to make the game for its primary platform, which was iOS. And then we later on also ported to the Wii U, PC, Mac, and Android. Can I see maybe a show of hands, who here has played Tengami? Okay, so it's a few, but it's not enough, so you'll have to watch the trailer. And in a nutshell, Tengami is an atmospheric adventure game, and it takes place inside a Japanese pop-up book. And you see this little blue paper man in the center of the screen. And essentially, players point and click or point and tap where they want that character to go. And they explore this very beautiful looking paper landscape. And as they explore, they come across puzzles and obstacles that players solve by flipping and folding parts of the pop-up book. And I think it's quite, to understand some of the reasoning behind why we made our own engine, and also later on to understand the tools that I'm going to be demoing, I think it's quite important that you know what the game looks like in movement. And that's why I'm going to play our Wii U launch trailer. At the very core of Tengami lies the idea, what happens if you take a physical paper pop-up book and take that into the digital world, to use for a video game. And I think that is, really that is like really important, and it's the core idea that led all of the technical decisions that we made on this game. Because what we saw when we saw, for example, there's like a lot of kids' movies that will sometimes use kind of like pop-up books as a setting. But when you watch these movies and you know a little bit how paper crafting and pop-up works, you can tell that somebody hand animated that paper folding, and that real paper would never move in that way. And so we spent a lot of time trying to figure out, the mathematical principles behind how paper folds. And in a nutshell, it's a lot of trigonometry. And so we were able to basically prove later on, and this will be, the tools that you're going to see, that we are able to make, digital pop-ups that are equal to their physical counterparts. And the two scenes that you see here, actually the digital scene on the right-hand side was built first, and then we went to a pop-up book artist, and we said to her, can you replicate this scene with paper and make it fold in exactly the same way that it does in our game? And unfortunately, the physical version is on display at a gallery at the moment, so I can't show it to you, but you have to believe me that it actually works. And so this brings me to the first part of this talk, the engine, and then the second part is obviously the companion tools. And so at the beginning of the project, we were Googling the internet frantically for a digital pop-up editor. And we didn't find anything, and that worried us a lot. And so we decided in the end, I'm going to talk about the reasons in a moment, to make our own engine. But I realized, when I showed the game at independent festivals or consumer shows, that there would always be a ton of developers that would come to me and ask me, is this Unity? And I realized that it is incredibly, uncommon in independent game development to do your own engine. And I found that a little bit surprising because the three games that I released in mainstream were developed with three different engines. So the first game was developed using Acquire's in-house engine. The second game used a commercial engine that's called Gamebryo. And when I joined Rare, we worked on Kinect Sports with one of the three in-house engines that they had. So to me, it wasn't, it wasn't per se very special. And I think naturally, the next question is, in the current climate, where Unreal is almost cheap, it's almost free. Unity is really cheap. Why would you do that? And so one thing that you need to remember, we started working on Tengami in 2010. And at that point in time, Unreal was not affordable to independent developers. And Unity was not as far developed as it is nowadays. And I think for me, the number one point, or the number one reason why you would be making your own engine is if you have a unique sales point or some kind of innovation in your gameplay mechanic. And in Tengami, that is obviously the pop-up book gameplay, but there's other independent games that have developed their own engine. For example, I think Limbo is obviously one of the most successful examples. Limbo is an amazing physics-based puzzle platformer. And if you play the game, you can see why they need to develop their own engine and their own physics system to create that kind of game. And there's also, some philosophical reasons. So because commercial engine, what's great about them is, that they immensely empower developers. But there's also, I think, a counter effect to it that we don't talk about very often, and that is that they impose also constraints on our creativity. Because commercial engines try to be, a one-fits-all solution, and they make assumptions of commonalities that exist between all games. And I'm even willing to go as far to say they define what games can be. And if you have an idea that kind of like falls out of that box, like you're not going to be able to use it. And another big point for us was, like, if I look at the time that it takes to make my own engine versus modifying an existing one, like what is going to be a better solution? And because at the time, and I still not to this day, like you don't get a source code access to a lot of the commercial engines, it's not possible to modify them at a very low level, which you might need. And even if you were able to do it, it puts you a little bit in a catch-22 situation, because you're essentially like having to maintain like your own version of Unity or your own version of Unreal next to the version that is being constantly developed. And I want to throw this up. So, like, despite popular belief, because I've been to a lot of sessions that tell developers never make your own game engine, it's actually not that difficult to do it, and I'll show you our approach in a moment. But I can't really stress that point more enough. Like, you need to have a clear goal in doing so. Like, you need to be laser focused on what makes your game special, and you need to be 100% convinced that you need to make your own engine and to realize your ideas. Because I believe that otherwise you will just end up with a piece of technology that is never used to create anything. And you need to make a decision, like, do you want to be an engine developer, which is awesome, or do you want to make games? And the engine is just one of the tools that you use to make a game. So what was our approach? We did something really easy and simple, and we created a minimal engine that only has the features that we absolutely need. And what does that mean? So, for example, our engine doesn't have a concept of lighting. We don't have a dynamic lighting system. We don't have shadows. The character shadow that you see in the game is just a circle, a black circle that is drawn under the character. We don't have a UI system. We don't even have a concept of 2D in our engine. And that saves you obviously like a lot of time, but at other times, like, there's also things where you run into trouble. So, for example, we have one instance in the game which is a pause icon that needs to be in 2D, and we need to do like a complete bodge around to get this most simple thing to draw on screen. We also made simplifying assumptions where we could. So, like, we don't have an elaborate shader system. Like, we only use two very simple shaders. One shader is used for applying the light maps that we bake in our tool. And, there's nothing difficult to it. Then I think the second piece to this is that you need to shortcut, we shortcut heavily by relying on existing middleware and open source libraries. And we like to use that approach like a use of best-in-class components. And why I call that best-in-class components, you will understand when you see what kind of middleware we licensed, because some of them is basically AAA stuff that was quite expensive to get. 95% of our engine code is written in C++ because we wanted it to be multi-platform capable, and we just use wrappers when necessarily, for example, to hook into Apple's Apple system with Objective-C. So just very quickly, I want to bring up here this library integration slide. So we decided that we wanted to use OpenGL for graphics. The wonderful thing about OpenGL is that everybody loves it, except for Microsoft, who we learned last week or this week, paid a very horrible man to develop the mess that's called DirectX. And but there's other things, because there's like Glued that makes it really easy for you to use OpenGL for Windows. So it's not a big issue. Then we integrate a lot of what I call here SKU-specific SDKs, which is obviously Apple stuff, Nintendo, Steam. And for example, with Apple, We use their gesture recognizers for our inputs. Nintendo, we supported they have collectible stamps. And on Steam, like one example for Steam is, I think we supported the cloud save. And so because we are not, we're not engine makers, and as I said, we don't want to be engine makers, we decided to throw money at middleware vendors where possible to help us, do a lot of shortcuts. Like we didn't want to do our own animation, physics, or AI system, and we didn't want to, spend time developing a visual effects system because the parts in our engine that we wanted to focus on was things relating to the pop-up book. And so I think like Havoc is a big question mark for an independent developer. Like, why would you use something like Havoc? Because I think everybody knows that they are quite expensive, but I mean, they're also excellent in what they do. And there's two reasons why we decided to go for Havoc. And one is that we were, that we had a lot of experience working with Havoc from our time in mainstream. And the other was that Havoc AI provided a crucial feature that we needed in our engine. And that feature is navigation mesh stitching. And so navigation mesh stitching in a nutshell is like I explained that Tengami, it's like a point and click. And you're walking through this world on your little navigation mesh, and then you start to change the geometry because you're flipping and folding parts of the world. And what that means is that at runtime, like you need to connect and disjoint navigation meshes as the geometry changes. Okay, so let's look at some of the pros and cons of making your own engine. And I think, obviously, one of the pros is that you have complete control, right? Over the whole process, over the whole workflow. You never need to wait on other people to fix something. You know something's broken, it's your own fault. You have the freedom to mix and match technologies. So whatever middleware you like, if you can integrate it into your engine, like you can use it. If optimizations and memory performance are important for you, then go ahead, knock yourself out. And it's obviously kind of quick to respond to SDK changes. If Apple changed something, like you can do it right away. But to be perfectly clear here, I think that the negatives actually outweigh the positives of making your own engine. Because one of the big things is that it's incredibly difficult to bring new people on your team. Because the way that they learn about your engine is by reading the source code of your engine. And that is just like a painful and incredibly slow process. Whereas if you used Unity or Unreal, people can do tutorials, or maybe they already have experience working with it. It's also obviously you need to keep updating. If you want to keep your game on the App Store, you need to keep updating it as Apple, whatever they think that they want to change in the next version of iOS. And I actually believe that it's really bad form to develop your engine while you're still figuring out gameplay. Because as as the goal of your design changes, it might be that some of the assumptions that you made when making your engine, turn out to be incorrect. And there's a high possibility that you need to, redo things. And, obviously nothing comes for free, because if you're not implementing a lighting system, then you're not going to have one. Whereas commercial engine, engine developers, they are always, very on point with, keeping their engines up to date and making sure that whatever is the, the feature technology of the moment will be supported by them. So despite all of that, would we do it again? And the answer is yes. And that is maybe, I think the answer to that is, for me, philosophical. And I just want to say that, I perceive technology to be a means to an end. But I want to be able, to freely imagine beyond what that technology is currently capable of. And, if by chance, and I'm not saying that I'm sitting around and that I'm just trying to think about games that can't be realized with current available technology. If that should happen one more time, then I would totally be up for what does this engine, and more importantly the tools that we create to work with this engine, like what do these tools need to be in order for me to find that creative fulfillment, to realize that idea that I have. Okay, like that's really all that I want to say about making engines. And let's have a look at the tools. So since we made that decision to do our own engine, it also meant that we needed to come up with like a level editor, a game editor, and what is here called the paper kit, which is really the heart and soul of Tengami. And how many people here are familiar with Modo? Very, very few. Okay. So Modo is a 3D modeling tool. In a nutshell, it's very similar to Maya and 3D Studio Max. And the single biggest reason why we decided to go with Modo is because it was cheaper than Maya and 3D Max. So it's just the money thing. But so Modo is almost never used in games. We might be one of the few games that used Modo for game purposes, but it's very often used in the movie industry for industrial design and visual effects. And one of the things that were really easy to do in Modo is write plugins via Python to basically make it do what we want it to do. And I will now attempt to do a live demonstration of the paper kit, and I'll show you our level, how we set up levels and things like that. Okay, so this is Modo 501. That's the version from 2010. Modo is now, I think, available in 902 or 903. So they've done a ton of work on it, but we basically stuck with Modo 501 through the development of the game because we didn't want to have to redo our plugins. Okay. Well, I'll just close that down and then reopen it. Okay, and so what you see on the left-hand side, where I'm hovering the mouse over, that is a paper kit, and that is the tool that we use to build digital pop-ups. And I gave a talk at GDC last year that's available for free on the Vault, where I talk a little bit more about the basics of the paper kit and how it works. So I'm not going to be able to redo the whole talk, but I think you'll understand. I hope you'll understand what's going on. So every pop-up starts with with what is called a plane fold, and I'm going to create a 180-degree plane fold, which basically just means that I'm creating a flat open card. And let's get rid of the dog. And so it's basically what I just have is like a greeting card that you can open and close. And what happens when I specify 180 degree while making the plane fold? What that means, or what that says to the tool is, at 180 degrees, the pop-up that I'm building is fully raised or erect. And here, like this, there's like this green shape, and the green shape is what is known in the pop-up in the paper crafting work as a valley gully. And the way that basic pop-up theory works is that you're trying to raise paper planes across gullies. And I'm going to show you how that works. And I'm just going to create a small box. Okay. I've created the box. And now I'm going to select what is known as the attacher. And I'm attaching it to this gully. And I'm selecting here the attach command. And so now that I've attached it, I can see, okay, yeah, the box is folding, and everything is how I want it to be. And I'm gonna attach like a few other things. So it's lying here on the floor. I'm selecting that, and I'm attaching it here to the box. I'm attaching it. It's just this little parallelogram, and it folds with it. And what it is, what I'm doing here in technical terms is, I said earlier that we didn't want to have to hand animate anything. Like we want all of the, all of the animation to be mathematically calculated. And essentially, when I'm attaching things to a gully, I'm building an animation rig. And it's unfortunately impossible to visualize where the joints are, but you just have to believe me, that I'm building a skeleton here. And then later on, what is happening is that the artist takes these animation rigs and starts shaping the geometry. So I think there's something wrong with the way that this is displaying. But I just want to close this and do another one. Okay. So most of the scenes in Tengami are actually 90-degree plane folds. And that is, that means, as I said again, the pop-up is erect or raised fully at a 90-degree angle. And this kind of structure is very easy to make pop-ups with because it's mostly like you're attaching parallelograms to it. And it's then really easy later on to edit these. And we also created a set of tools that I'm going to show how we are editing this with. And it's maybe worth noting that the paper kit doesn't really check whether what I'm doing, whether that is a valid construction. So I'm also able to just, create really bizarre things that might not be able to fold like that in the real world. I'm going to detach that one because this is not what I thought it would be. And I'm going to delete it. Okay. 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 I'm going to attach that here on top. I don't know why I'm creating like all these flat planes. Okay, so there's a few neat things that we did later on to edit the pop-ups, and okay, let me see if I can. Like for some reason the text isn't showing up what it is. Okay. So there's a way to kind of like, because what we're dealing with most of the time are kind of like, flat paper planes that can be rotated at various angles. And as such, it is really easy to use something what we call stenciling and shaping. And I've here created a, what you can see, it's what some of the bushes in the game look like. And I'm going to show you like how you can stamp and stencil that shape into this plane that I created in the back. And so these are what we call the Nyamyam tools, that are just tools that we created to help us with editing the pop-ups. And I'm going to say, snap to top. So what you see what happens is it perfectly aligns it to that mesh. And I'm pulling it down a little bit, and then I'm saying, okay, stencil. I don't know, like I'm doing it wrong now. I think it must be nervousness. I don't know why I can't figure this out. I tested it earlier and then everything worked. Well, so in theory, I apologize. Like what should be happening is that you can see you get like the exact same shape here in the back mesh. Oh well, never mind. Okay, so let me just see how much time we have left. Okay. So a lot of the scenes in Tengami are basically, like this kind of 90-degree, and then you just layer a ton of parallelograms on top of each other, and you edit it with this kind of like stenciling, or sometimes you can also just attach decoration, which is probably not going to work now either, which is kind of like, so maybe I'm just going to try and attach it to here. I'll say snap to bottom. You see that the bush, appears on the plane and is perfectly rotated to it. And then I move it around where I want it to be. And then I can just say, merge these meshes. Because if I'm, if I'm folding right now, you can see that this little bush isn't moving, isn't animating with it. But if I merge the meshes, then now, it's part of the mesh, and that works. And, using this as a stenciling, attaching decoration, just like in the way that you would glue on paper, pieces of paper in real paper crafting, is a really efficient and fast process to do things. And maybe if you want to see it properly, you can come and see me later, because I'm going to have my laptop with me, the whole day. And so I want to show something else. So we also have in Tengami things that are kind of like architectural based. There's, for example, a lighthouse. We have shipwrecks. We have a bunch of Japanese temples, and we developed some tools to allow us to easily make these, because these kind of structures can be quite difficult to figure out. And I hope that that's going to work. So, right. So what you see here is the profile of kind of like half a lighthouse. And in the paper kit, we are having what we call creation utilities. And there's here one that I want to show, and that is create shape from profile. So I want to create a V-fold-based lighthouse together with a base. And I'm kicking off the script, and that is going to take a minute, maybe two, while it's trying to calculate how to, create this shape as a realistically folding pop-up that could be recreated, with paper, scissors, and glue. If it spins for more than 2 minutes, I pre-created this prior to the session, so I can show you that it works. Yes, okay, one success today, and I specified at the script that I wanted to have a base card already, so it's already attached, and you can see. Let me turn off the mesh. I created this, if I were to do this by hand, I've done a lot of, obviously, making of pop-ups, digital as well, physically in preparation for this game. But if I was given an image of this kind of lighthouse, which is inspired by a real lighthouse in Japan called the Sumiyoshi Lighthouse, it would take me, several days trying to figure out the correct structure of doing this. But with this awesome tool that we created, I just made a profile shape, and then it gives me this lighthouse, and it folds. It folds beautifully. And I know that if I gave this to a pop-up book artist, they would be able to analyze, what our tool calculated and replicate the same thing with paper. And I think that's really the amazing thing. And it would be wonderful, if there was a way for more people to kind of experience this tool and what it can do. But I hope that you got at least a little bit of an impression, what is possible, and also how much work went into developing this tool. And okay, so I think we have about 7 minutes left. And I want to stop the demonstration here, because the other things that I could be showing would take definitely more than 7 minutes to explain. So if you want to ask some questions, then now is the time. Yes.
Does your tool take into account the thickness of the paper? Because you put really
Yeah, it does take into account thickness of paper, but it doesn't take into account paper weight. So a lot of the structures that we built, and so we created several physical pop-ups based on the game scenes. And this is one thing that the pop-up book artist came back to us with, and she said, the things that you do work because like your paper has indefinite strength. But if I have to do this, with paper, like I need to either work with incredibly like thick paper, or it's not gonna work. And essentially, in paper pop-ups, the thicker the paper, like the more difficult it becomes to make it fold. Yeah. Yeah, go ahead.
Are you giving this kind of specific technology? Are you reusing it for other projects, or for example, I can imagine that you have like a general service to make some digital folding books or something like this. I think you have thought about it. Is there anything, or are you giving this technology away in some kind of way?
So we are not giving it away at this moment in time. And the biggest reason for that is that people who would be able to use the tool are people that are very familiar with how pop-ups work. And you would need to have a really deep understanding of how it works, which obviously, people can learn. And the other reason is that because we are only 3 people, and the moment that you start, even if you give it away for free, I think there's a little bit of an expectation that you give customer support and explain to people how things work. And we didn't write any kind of documentation, and there would be a lot of work involved for us to make it, available to other people. And I think the third part to the question is yes, we still want to use it for other games, not necessarily like a Tengami 2. But, while working with this, I saw potential for, any number of games that could use pop-up as a game mechanic that are, drastically different to what we did with it in Tengami. And yeah, we always hoped, that a pop-up bookmaker would come to us and say, hey, can we license your product to bring our paper books, to the App Store? But that hasn't happened. Mm-hmm.
Shape, and you know what I want to say, so you could easily separate it, right? Because I think it's really cool, and you could make so many different things with it, not only just Tengami 2, but much more.
Yeah, of course, yeah, you're absolutely right.
It's really impressive.
Thank you.
And I would like to use it.
Yeah, go on. Mm-hmm.
So I want to know, are the pop-ups you made Tengami, so made from one sheet of paper? Could you technically make them physical from just one paper, or would you have to use several stuff on additional pieces of paper?
No, you can. So we looked a lot at kirigami as well, and I did a lot of hand kirigami. And essentially, what kirigamis are, it's everything is parallelogram based, but they have already calculated the shape of the final parallelogram. I don't know if that makes sense. And it would be absolutely possible in our engine to do kirigami, with just the one sheet of paper, if you knew the kind of shape that you want to create in the end. Yeah. Yeah, it's cool. I'd like to see it. I think because kirigami is, I don't know if many people are familiar with it, but it looks very beautiful. Are there any other questions? I think we have time for one more question. Go ahead.
How long were you building the game for?
3.5 years. And 1 year was developing the paper kit. And the engine actually didn't take so much time. I mean, because we were essentially just integrating existing, libraries in middleware. Well, okay, yeah. Thank you very much.